Okay, so moving ahead, our next speaker is Mr. Nirav Kothari, who is a engineering head of data and analytics on GCP. We would like to call them on stage.
Please welcome Mr. Nirav Kothari.
Okay. Am I audible? रबड़ी खाया है लब लोगों ने लगता है काफी नींद आ रही है सबको. Okay, anyways, okay, so I am a Google developer expert in cloud platform category. I am a co-organizer of GDG Cloud Mumbai chapter, and I'm working as a senior technical architect at Quantiphi. I'm going to talk about, how do you do data engineering with Google Cloud? Okay, we have seen that bunch of cases, use cases around ML, right? Machine learning, AI, etc. But for all those use cases, you need data. How do you get the data in the system? And how do you use that data? How do you store that data? That's where data engineering comes into picture. So I'm going to talk about how can you get started with that, and how can you build your career as a data engineer in any of these organizations. Okay, moving on. This is the small agenda. I will take a use case. A small organization. How does a small organization starts with a very basic application and grows into an enterprise level application? You would have seen Swiggy, Zomato, all of these applications. They started very small, but now they are a huge application. And how did they become a huge? What all system went into it? That's the kind of use case I'm going to talk about today. I'll start with that. Then to build that, what kind of development roles are involved in the organization? I'll take you through that. And then I will zoom into what is the responsibility of a data engineer in such a huge environment. What kind of activities they do in their day-to-day work. And then finally, I'll speak about what are the kind of projects that you will have to execute being a data engineer. Okay, moving on. So this is the entire development landscape. Okay, usually organization, not sure whether it is readable. Okay, so usually organizations start with a very small applications, web applications, maybe mobile application, maybe web application, and it must be storing some data in its database, right? So that's what it is, transactional database. But as the organization matures, they either implement microservices based architecture, or they keep on building new applications in their portfolio, right? So you might end up having multiple web applications, each one of them writing to their own databases, right? But you don't get a visibility of all the data spread across multiple databases, right? And that's where you need a data warehouse where you collect data from various databases and put it into one data warehouse. And that's where you use a technology called ETL, extract, transform, and load, right? And that's where you implement this data warehouse. Now, I intentionally called it as data platform. At this moment, this data platform has only one component, that is data warehouse. But very soon you will see that, your data platform is much more than a data warehouse. Okay, moving on. So what do you do with your data warehouse? You create some kind of analytics on top of that, right? It could be a BI analytics. So your managers, your sales managers, maybe top managers will, create some dashboards, etc. on top of that data warehouse, right? And that's where BI tools come into picture, right? Then you think that, since we have data warehouse, why don't I ingest more and more data into my data warehouse, right? Information from various other systems, CRM, SAP, HRMS system. You try to collect data from all these sources and again put it into the same data warehouse so that you have larger context in your data warehouse, right? And that will allow managers to, do much more analytics on top of that. Moving on, now that you have systems, data coming from multiple systems, you would like, and from different business department, you would like to have, some kind of data marts. Now that will help you to strategize your reporting dashboards according to your business function, right? And that's where data mart comes into picture. Now, many organizations feel that, our application servers, our web servers are generating a lot of log files. We don't want to lose those log files, right? Let's keep it, let's store them. And where do you store it? You again have to store it in your data platform. But does data warehouse support storing your files? Of course not. And that's where, you will have to come up with something called as data lake. Now, you think about it, the data platform has now, grown up from a data warehouse to data lake plus data warehouse plus data marts, right? And at the same time, I have also shown that, some images, some video files you might be capturing from your some systems, that also you want to store it. And that's where, you need data lake. At the same time, now that you are collecting so much of data in your data warehouse, you might think of, implementing some predictive analytics, some ML use case, some AI applications on top of that data. And that's where you start building that, the predictive analytics on top of your data. At the same time, you might also think of, getting data from streaming systems, say Twitter feeds, or maybe stock market live quotes, right? Those streaming data is also coming into your system. So that's how, you started with a very basic one application in a database, and now your system has become such complicated. It has so many components, into it, right? And that's where the system has become much more complex. But do you think that all these responsibilities being done by one engineer in your organization? Of course not, right? You will have multiple engineers and at the same time multiple teams. Now, what are the different teams that we will have to, your organization will have to employ to implement this such a huge system? Let's look at that. Now, look at the top right corner. Those are the 4 different roles that any organization would have to implement such a complex, system. One is application developer, data engineer, BI engineer, and ML engineer. But out of this entire system, which one is responsible? Who is responsible for each of these components? Let's look at that. So what you see, the pink box is something that is app developer, the application developer is responsible for that. Everything that is in green color, that is data engineer's responsibility. The managing of databases, writing ETL components, ingesting this, flat files, image files, video files, log files, that is the responsibility of data engineer. Pulling data from enterprise applications is data engineer's responsibility. Streaming ingestion and streaming analytics is data engineer's responsibility. Managing the entire data platform, data warehouse, data lakes, data marts is data engineer's responsibility. Moving on, the blue box is basically BI reporting. So that is being done by BI developer. They create nice visualization, dashboards, some charts, etc. So that's the responsibility of BI developer. And the yellow box that you see is basically AI and ML. So data scientist usually is responsible for all that. Now let's zoom into one more layer. Let's focus only on responsibility of a data engineer. Okay, so everything that you see in green is data engineer's responsibility. Now let's name all these 4 responsibilities. So these are the only 5 tasks a data engineer is supposed to do. Okay, and what are those 5 tasks? Database management, the first one. Building data pipelines. managing data warehouse, which is called as data warehousing, then batch ingestion and streaming ingestion. So these are the only 5 tasks that a data engineer has to do. Rest of the time he can sleep, So that's how it is. But do you know that what, by these 5 functions that I talked about, what are their day-to-day routine looks like? What are they supposed to do? Here it is. Okay, I have zoomed those 5 functions here. Let's look at what he has to do. Okay, so database management, he's supposed to first of all select what database should I select. Should it be a relational database? Should it be NoSQL database? Okay, should it be columnar database? That selection is data engineer's responsibility. Usually, when you are not into cloud world, you have to think about what should be the size of my database. Would I be requiring 100 gigabytes of RAM? Hard disk, or would I need 1 terabyte of RAM hard disk? So database sizing is required, but in cloud world, you don't need to do that because it's all dynamically scaling, right? Auto scaling. Moving on. The third part is schema creation. What does that mean? Basically, you create tables and what columns, what security, etc., etc. Database performance management is something responsibility of data engineer. And of course, database security, passwords, all of that, what IP address should be accessible, what firewall rules, etc. And the last is basically how do I make my database, having read replicas, highly available, and how do I make it disaster recoverable, right? So these are the 5 functions that a data engineer does as a part of database management. But how do you do it in Google Cloud? These are the 4-5 types of databases available in Google Cloud, and each of these databases support all these functions out of the box. So you don't have to do much. A lot of your heavy lifting stuff is already being done by Google Cloud. Moving on, let's look at the data pipelines. So as Vijay also was mentioning that we need to select what approach, ETL or ELT. You want to transform before ingesting the data, or you want to ingest the data first and then do the transformation. So that's the approach that a data engineer needs to think about, right? And that's where this task is basically. The next is how to connect various data sources, how to connect the destination, whether JDBC connector is optimum or maybe REST API is good enough. So that's the kind of decision a data engineer has to take. How do I transform the data and what all transformation is required? Do I need to change the date format? Do I need to cleanse the data? Do I need to remove certain data, filter out certain data? So that is the kind of transformation, right? That's a responsibility of data engineer. And finally, the orchestration. So how do I, what time my pipeline should run? Is my pipeline dependent on certain thing, dependencies and all of that? So that's a data engineer's responsibility. And of course, not just developing it, after developing, you monitor it, right? Every time you run it, whether it was success, failure, if it was failure, how do you solve it, right? Okay, moving on, let's look at the data warehousing part of it. Okay, sorry, I missed this part. So what is service available in GCP to help you with this function? Basically, data fusion will help you to create data pipelines in a drag and drop manner. Data flow is script based, but it is very simple. I mean, if you have to write certain code in Python, probably you will take 100 lines. In data flow, you can do it in like 5 lines, right? So it's much more very abstract, and at a very high level, you can code your data pipelines. Of course, Dataproc will help you to create Hadoop cluster on GCP, and then you can create Spark kind of script to process your data. You can use Composer for orchestration of your pipelines. Moving on, data warehousing. you have to decide, as a data engineer, you will have to decide whether you need a data warehouse or a data lake. Of course, many of you do not have that understanding. What's the difference between warehouse and lake, right? Does anyone know that BigQuery can also be used as a data lake? Exactly. So you need to understand the concepts, and BigQuery is a very flexible service created by Google Cloud. That you can model it as a data warehouse. You can model it as a data warehouse also, and also data mart, right? So you need to understand what to use when, right, and how do you build it. Choosing the right storage mechanism and analytics engine, right? So that is something data engineer's responsibility. And of course, when you talk about data warehouse, it's very important that how you model your data. What table should be there? What is the relationship between the tables, right? And do you need, star schema? Do you need, and all of that, snowflake schema and all of that. So that is data engineer's responsibility. Okay. Most important in data warehouse, data governance is very important. Now, when you say data governance, it covers a lot of things. How do you organize your data? You might have multiple department in your organization. Finance department, accounts department, HR department. Each of these must be storing data in somewhere, right? You need to actually somehow, organize this data in such a way that, it is easily searchable, right? So data governance is one part. Apart from that, data quality, data security, all of that is covered under data governance. And if you leverage BigQuery, Google Cloud Storage, and Dataplex, you will be able to do most of this data governance part. Okay, moving on. Batch ingestion and streaming ingestion is nothing but, how do you ingest your data in Google Cloud in streaming fashion, in batch fashion, etc. There are various services available in Google Cloud to ingest your data in multiple of this fashion. But understand that data engineer is responsible for all these functions. Okay. Moving on. So in case if you plan to switch your career into data engineering, I'll just brief you about what kind of project you will have to work on, right? So there are three types of projects in data engineering. One is data warehousing, right? Now what do you do in data warehousing? You collect data from various sources, be it databases, be it files, be it APIs, or maybe something else, maybe FTP server. You pull data from all of this, transform that data and put it into your data warehouse, right? So that is one part of project. The other part of project is migration. So a lot of organizations want to migrate their data warehouse from, let's say, other cloud provider to GCP or on-premise Hadoop to Google Cloud, right? So they want to migrate all of that, all their data, and not just the data, but every pipeline which is feeding data into those data warehouse, those pipelines also need to be migrated. So that is second type of project that you will have to work on. The third is data governance, as I mentioned, where you set the governance process in the organization about how to secure your data, how to ensure quality of your data, how do you organize your data, what access should be given to what data. Those kind of, thought process you need to implement in the organization, and of course technologically. So that's about it. And in case if you have any questions, I'm already running out of time. If you have any questions, you can connect with me on any of these platforms, or I'm here up to some time, and we can connect offline. Thank you so much. Bye bye.
Thank you, Mr. Nirav, for delivering such an exceptional talk. Your expertise and knowledge have left us profound impact on all of us.
So I would like to call Dharmesh sir and Vaibhav sir to felicitate Nirav sir.